In this lesson, we're actually going to be calculating some sine, cosine, and tangent values. Now, because of that, you're going to need a calculator handy, and you're going to need to make sure that your calculator is set into degree mode as opposed to radians. We will be learning about radians, but we're not using them today. So you do not want your calculator in radian mode. If you're on a graphing calculator like a TI-83, TI-84 type, you're going to find that option under the mode button. So you'd press mode and then you can arrow down to fix it and set it into degrees there. Other calculators have it in different areas. So look up there, like some of them, some calculators, you'll actually see a button that's labeled DRG, which stands for degrees, radians, and gradians. So you press that and it changes. If you're on one of those type of calculators, at the top of your screen right now, you would probably either be seeing DEG, RAD, or GRAD. If you see one of those on your calculator screen right now, that's telling you whether it's in degree mode, radian mode, or gradient mode, and you want it to be in the degree mode there. Now, if you are just simply not sure which it is, there's a nice easy way to be able to check it. If you plug the calculation into your calculator for sine of 30 degrees, it should give you an answer of 0.5 if you are in fact in degree mode. If you're not, it's going to give you some wonky looking decimal. And then the one last thing I'll say is that if you are trying to do this check and you're not even sure how to type that in, it does depend on what happens on your calculator. So look on your calculator and look for the sine button. When you press it, what happens? If, when you press that button, you see on your calculator screen and it actually pops up something that looks like this, it actually shows sine and then starts parentheses for you, then you're going to press that sine button and then you're going to type in 30 and then you just press the equals button and that'll do it for you. If you don't see something that looks like this, instead, when you press the sine button, it comes up with some decimal on your screen, or just shows 0 on your screen still when you press that sine button. That means that you're probably on a scientific calculator, and in that case, you actually first press 30, and then you press the sine button at that point. And if you do that correctly, then that will actually show the 0.5 on your screen as soon as you press the sine button. So make sure you got that part figured out so that you can get this calculation, sine of 30 degrees equals to 0.5, before you go any further. Otherwise, nothing else here will work. So take the time, make sure you got that working, and then we go on. All right, we are going to just calculate each of these three values to make sure that we got the whole routine down about how to do these calculations. So we're going to calculate first sine of 60, and yes, I do want you doing these calculations on your own to make sure you got those ideas down. So type this into your calculator. When you do that, for sine of 60 degrees, you should be getting an answer that looks like this. Now, depending on your particular calculator, you might see more or less decimals in that. The decimals keep on going and going and going. But the fact that the decimals keep going on and on and on means that we cannot actually write this number, this decimal that we're seeing here, exactly. It is an irrational number. But we can round it to something. We can round it to 4 decimal places. And so if I want to round it to 4 decimal places, then I count 4 places out from my decimal. Okay, so that means I'm cutting it off right here at the 0. Remember to look at the one next number. It doesn't matter what the rest is after that, just the one next number for your rounding. In this case, since that next number is a 2, you're just going to call it 0.8660. Now, as a total side note here, in our last lesson, we were taking a look at some special right triangles. And in those, we actually saw what this exact value was. So we didn't talk about it in that context then. We will. It turns out that we actually could know that exactly if we write it as root 3 over 2. But that's the difference between an exact answer and one that's been rounded to 4 decimal places. All right, let's continue with our work here. The next one is cosine of 45 degrees. So go ahead and make that calculation, get that number on your calculator. And as a side note, yes, this is another one that we could actually get exactly it would be root 2 over 2, just kind of as a preview about where we're going to be going with that. But I'm not asking for exactly here. You got that number on your calculator now. It should be looking like this. It's another one of those irrational numbers, one of those decimals that goes on forever and ever, never repeats itself, so there's no way to actually write the entire decimal. That's why the exact answers come up and why oftentimes we need to know the exact answers, because we can't write these decimals down. But for this case, all we got to do is round it. When rounding this one to 4 decimal places, we end up with 0.7071. And again, repeat the process, please, for that last one. Tangent of 85 degrees. And with that number showing on your calculator, let's see how you did. You should be looking at this number right now. And again, we need to make sure that we're rounding it properly. And if I put in a line there right after that 4th decimal place, I look at the 1 next decimal and I see that it's a 5. Now, since that's a 5, that tells me that I'm going to go ahead and round this number up 1. And so that's why we would actually say 11.4301. Now, one other little detail out of these 3 problems, if you had a keen eye as you were looking at it, you might have noticed that in the first and the last problems, I wrote sine or tangent and then just the number. Whereas in the middle problem, I wrote cosine, but then I put parentheses around the number. Which is right? Technically, if we wanted to be very, very careful and purposeful, we really should be writing the parentheses around it each time. Because remember, this is a function. And the parentheses are there as part of the function notation. However, because, mathematicians like to be lazy and they like to find shortcuts, it is considered acceptable to write it like this, without the parentheses there. However, I would definitely say that I prefer that you write the parentheses, partly because later on, we will be looking at some more complex types of equations, like we might look at something like this, sine of x plus 1, a nice little simple one. That actually means something different than that. So all of a sudden the parentheses do matter later on. So I would just get in the habit of putting them in all the time now. That way you don't have to worry about do I or don't I later, because they're always allowed. Okay, we are now going to practice calculating these values, because you will also be able to need to do these calculations to do some of the solving that we're going to be doing. So first up, I want to make sure that we know what it is that we're actually looking at when we look at that. Now, we've actually seen some stuff that looks like this before, just in a slightly different way. Now, obviously, we've seen sine of something before. We've also seen something with that power of -1 before. Remember when we were doing stuff that looks like this? Remember that in this case, that power of -1 meant that it was the inverse function. The same thing is true if I put the -1 on the sine like that. It's just, notice in that spot there before the parentheses in both cases. And so for that reason, when I look at that expression, what I'm reading is inverse sine of 0.4. And that's how you read that particular function that you see here, is inverse sine of 0.4. Now that we know what to call it, we need to actually calculate it. On your calculator, it is almost always second and then the sine button to get to the inverse sine. And you push that button in the same order that you push sine. So if you had to push sine first on the last set of problems and then you enter your number, you're going to do the same thing with inverse sine. If you had to enter the number first before and then press the sine button, same thing here. You're going to have to enter the number first and then press second sine. All right. Now, let's check that you can actually get the right number out from that. Practice doing this. Make sure that you can get the right number out. This is the number that you should be looking at on your calculator if you're doing this calculation correctly. If you're not getting it right away, play with it until you get the right order down, and then make note what that order was so you know how to be typing this in properly. And then now that we have our answer, we can see like the big long decimal. In this particular set of problems, we are being told to round to 2 decimal places. And so I go out to the second decimal place, and so that's where I'm going to be cutting it off. The only question I have to answer is it going to stay a 7 at the end, or is it going to roll up 1? Those are the only two options when rounding, remember. In this case, because it's an 8, that means it's going to round up. And so our final answer is 23.58. Now you notice that that is degrees. Whenever we do inverse sine of a number, it gives us an angle. And so inverse sine gives us 23.58 degrees because we are, of course, in degree mode. And once again, you'll notice that we have a little bit of variety where some of them have the parentheses around them and some of them don't. It's the same deal as the last ones that we were taking a look at. It is better to include them than to not, but it is acceptable in this scenario to leave them out. All right, if you have not done so already, please do the next calculation here, inverse cosine of 0.75. And then check to see that you got the correct number showing on your calculator. And then we move to rounding. And you'll notice to round to the second decimal place here. The next number is a 9, which tells me, yes, I'm going to have to round that 0 up. And so we get 41.41 degrees. And then, again, repeat it for this last problem. Plug that in. Make sure you can get the right number out, which should be this. And then, again, we round our final answer. And so we go to where that second decimal would be. And then it's just a question of, is it going to be 6.6 or is it going to be 6.7? And because the next number is a 9, that tells us that it's going to be a 6.7. So our final answer there is 41.67 degrees. Now that we've gone through those exercises of just calculating these values, you now have all the tools you need between this and other things you've learned to be able to solve an equation that looks like this. And so we're going to solve this and one more to be able to see how we can apply some of those things we already know. So first of all, I want you to notice here that the x is inside the parentheses. That is, the x is inside of the function. That means I have to get rid of this cosine. And I want to get out of the way right now a big misconception that I'll sometimes see people say, because I'll sometimes see people write this on their paper. It looks like cosine times x, so I'm going to divide both sides by cosine. This does not make sense, actually, because cosine is nothing on its own. That'd be like saying I'm going to divide both sides by square root, to which I would say square root of what? Because you can't divide by a square root. It's a function. It always has to apply to something else. The same is true of cosine here, where cosine does something to x. It is nothing on its own. And so you cannot divide by cosine. Instead, we need some other way to undo cosine. Like with the square root example, remember we would use square root to undo something when we have like x squared. We use square roots to undo the squared. It's the inverse operation of squaring. Inverse. We need an inverse. Well, we recently saw an inverse, didn't we? We saw what the inverse of cosine looks like. And so we can actually use that inverse cosine function to solve this. Our first step here, in order to get rid of cosine, is to take the inverse cosine of both sides of the equation. When we do that, doing inverse cosine of cosine, because they are inverse operations, it cancels it out, which is why all you're left with over here on the left side is that x. And on the right side, though, because we also had to do the inverse cosine on the right side, you now have that inverse cosine of the 0.25 over there. All right, now I can figure out what x is, because all I have to do is now calculate the value of inverse cosine of 0.25, which after the last set of exercises we did, we now know how to do. And so we should end up with a final answer here of about, because we're rounding, 75.52 degrees. And yes, you do want to include that degree symbol. Remember that whenever we do inverse cosine or inverse sine or inverse tangent, we get an angle out as our answer there. All right, last problem for this lesson. We're going to look at how we would solve this equation. Notice in this case, we're starting with inverse cosine of x. And I need to get rid of the inverse cosine part so that I can have the x left behind. Well, what's the opposite of inverse cosine? Well, you saw it on the last problem. If inverse cosine can be used to undo cosine, then cosine can be used to undo inverse cosine. And so we take the cosine of both sides of the equation. And in so doing, again, that means that you're canceling out the cosine and the inverse cosine. And it's just leaving you with that x value. But of course, you had to do it to both sides of the equation, which is why you're going to have cosine of 20 degrees over here instead of just the 20. And again, plug it in your calculator, get your answer here. When we do cosine of 20 degrees, you should be getting an answer of about 0.94.